My name is Bob Suters. I'm the CEO of IPStar. I'm going to talk a little bit about the technology transfer activities of, not for whole ESA, because that's a little bit too much, but for one space program which is called the Melissa. I'll explain what that is. First a little bit about ESA, but I guess most of the people in this room already know about ESA. So it's the European Space Agency. We have 22 member states. Annual budget in 2017 was 5.25 billion euros. The largest R&D facility of ESA is actually in the Netherlands. That's this picture. You see, it's quite a large facility. It's nicely situated in the dunes, very near to the sea, which is for us it's very extraordinary. For you, perhaps not as much. The distance between Moon and Earth is very small. If you want to go to the Moon, you will travel about 3 days. So basically, you spend a week there and you come back and you can bring all the food and water that you need in your space. However, if you want to go to Mars, or perhaps even further, that's a completely different ball game. We are looking at a one-way trip of about 9 to 12 months. So you stay on the planet Mars until the planets are in the right position again for the return trip. And all in all, we calculate that you would need about 1,000 days to go to Mars, do your science and research there, and return to Earth. With a crew of 6 people, that would mean that you would have at least 30,000 kilograms worth of water, food, and oxygen. But this is the bare minimum. This does not mean that you can brush your teeth, using water. This is just for drinking and eating. Has anybody seen the movie The Martian? Because if you have, then it will be quite clear what we are doing, because what Matt Damon has been doing in 1 week, we have been doing since 1989. And it was almost 30 years now, and it's estimated that we are halfway our effort. So we expect, basically the goal is that this was formulated by a set of visionary scientists. Like I said, almost 30 years ago now, they said, well, we can do 2 things. We can build bigger rockets to bring out supplies, which is the solution of Elon Musk, who was already mentioned earlier. Or we can perhaps try to build a system that is smarter, so we can make use of the resources that we will have and produce them on site. So this is the decision, or this is the approach that was taken by the European Space Agency. And the idea basically is to reuse everything that leaves the human body. So I will not go into details because it's right before lunch. But fecal matter, urine, and CO2 is being reintroduced into a system, into a closed loop, and that's being used basically as a source to produce food and water and oxygen on site. So this program is called the Melissa program. So we are now a 60-person organization, so a lot of universities, of course, also companies. We have about 100 scientists and support staff, and it's quite a large initiative, and it's one of the longest space research programs that has been running ever. The goal is very simple: to design and build a 100% closed loop life support system. It's a very easy sentence, but it's not easy to do, I can assure you. So these are the 14 partners that have assigned to the MOU. So you see on the left-hand side a few universities, of course. One of them in Spain and Barcelona. At least now it's still in Spain. We don't know what's going to happen. We have some research institutes in Belgium, SSK, and Vito. There are 3 commercial companies. One is IPStar, my company, Sherpa, Enginesoft, and one foundation. It's called the Melissa Foundation. That's based in Brussels. So as you can see, we have quite a nice geographical spread, but of course we also work a lot, with the Russian Space Agency, with the Japanese and the Chinese as well, and of course with NASA. So why is this interesting for Earth? Because the challenges that we have in space really are focusing or centering around water, waste, food and energy. More specific, the latter of basically, because you are in a confined space and all that you have is material. So these are the challenges that we are also facing on Earth. You know, we are now 7 billion people, but we will be 9 billion people in 2050. Half of these 9 billion people will be living in very large cities. And all of these people will need access to clean water, to food and to sanitation. Today that practically is not possible. So we have to look for new ways how we are going to maintain all these people, to keep them safe, keep them healthy, keep them fed, and keep them hydrated especially. So the solutions that have been developed for space, for the space challenges are really a big inspiration, and it can be very helpful also for the challenges that we have here on Earth. That's the mission of IPStar. The mission of IPStar is basically to transfer the space technologies to Earth, and that means that, for example, if for space you want to develop a 100% closed system, for Earth that is not needed, because we have resources, we have our oceans, we have air, we have food. It is just that in the velocity that we are now consuming our resources, we are eating up the Earth, and that's a limited system, and we need to do something about that. One of the new concepts that has arisen is circularity. That means reuse of what you are using. Basically, if you buy a jeans, it has been produced using a lot of water. Maybe after 1 year, that jeans is not in fashion anymore, so you want to buy a new one. What used to happen is that you throw away that jeans. What we want to do is that you are going to reuse the jeans, but not only your jeans, also your cell phones and your car and your house and everything basically that people use. That's called the circular economy. So that was a bit of an introduction of Melissa and what is basically the broad concept of IPStar. I was asked to give you a few examples of projects that have already been transferred from Melissa program to Earth. So I'm going to give you a couple of examples. So it's not surprising that most of our projects are in agro-food, life sciences and health, water and waste. So we are here in the south of Spain. We all know that you have quite a challenge in terms of water availability. There's a tendency that it's becoming drier, it's becoming hotter. So that means that this challenge will only grow. So that's why I'm glad to be here, because I hope to be able to provide some contributions to solutions to your challenges here. To start with water, this is actually quite an old technology. It was developed by Melissa, and this was adopted by Veolia. I don't know if you are familiar with the company. It's a large utilities company. They have bought, I should say, this technology, and they have used this as a basis for water treatment. It's being used all over the planet now. Hundreds of millions of liters of water are being treated by this Melissa technology. At that time, we were not so smart. We didn't ask any money for it. So if we had asked, for example, 1 cent per cubic liter, then we would be very wealthy, but we didn't do that. So this is a picture of a water treatment plant in the north of Morocco. The groundwater was very polluted, and they asked us basically, could we design and build a system to treat this water, which we did. This was opened 2 to 3 years ago, if I'm correct. This is a picture of a wall. I mean, air is obviously a very important issue when you are in space, every second really. So it is very important that you purify the air and that you take out all the stuff that you don't want. So there are different kinds of technologies. This one was developed for space, and this is being rolled out now in North America quite successfully by a company. As you can see, it also looks very nice from the aesthetic point of view. It is very efficient, it is very cheap as well, and this is being sold, so to speak, in North America and in Canada, not in Europe yet, but this may change if we find an entrepreneur who would be interested to do it. This is a picture of a research facility focusing completely on microalgae. Microalgae have a great future for space because it's a fantastic source of different type of foods for the astronauts, but also it also produces a lot of oxygen. If you develop the challenge with algae is still that it is very expensive to produce it for industrial purposes. So if you want, for example, if you want to make biodiesel, it cannot compete with existing technologies. So this is why we are associated with this initiative in France, in Nantes, where we are studying the production of microalgae, and we have now come to a stage where we can produce 15 to 20 times as much algae within a cubic volume compared to conventional systems, which makes it very interesting because then you are reaching actually a point where you can economically, feasibly commercialize and produce algae. So this is still at the research phase, but we are almost at the breakthrough, and then we can start actually rolling out different kinds of products with this. This is something that came out of the Melissa program as well. It's a bit a non-typical project. We use a lot of microorganisms in Melissa to treat basically the waste that's being produced by humans, by the crew. And one of these microorganisms, almost 15 years ago, by TNO, which is a Dutch contract research organization. And what they found out that it is very safe to eat, but also what happened is that it lowered the bad cholesterol with almost 50%, which was not the intended goal of this research, but they just found this out. So they wrote a patent, which was granted a couple of years ago, and we bought this patent back from TNO, and we have now been involved in a quite extensive research phase. And we are now getting ready to start the first human trial. This is very interesting for companies such as Pfizer, but also for DSM or other companies that are active in the food industry. This is a project that we did with the University of Applied Sciences in the Netherlands. This is a picture of the Amsterdam Arena, or I should say now the Amsterdam Johan Cruijff Arena, as it was named very recently. What we did is we did a study to collect the urine of the visitors of the matches and the events. So as you know, soccer players drink a lot of beer, so they go to the toilet very often. And what we did is we collected the urine, and we are going to extract the nutrients that are still present in the waste, and we are going to use that as fertilizer for the grass, basically. So this is for India. India is quite a small water treatment plant, but it is twice as big as the biggest water treatment plant in the Netherlands. So when we first came here, we were a bit surprised to see the size of it. This is a project that we're doing together with TU Delft, with Wageningen University, and with some other partners such as UNESCO. Basically, they are interested in new technologies to help them solve the huge challenge that they have in terms of water treatment. I don't know if anybody has been to India. I'm sure many people are here. And, then you must also be familiar with what they call the Delhi belly. It's if you drink water, you know, you will not be able to leave your bathroom for the next 2 days. And this is a project that is really looking into the cutting-edge technologies of treating water, not only cleaning it, but also recovering the nutrients that are still available in those waste streams. And then you are coming very close to the principles of the circular economy. It's not only treating water and cleaning it for drinking, but also recovering what's still in there. And then you can use that to fertilize plants, or you know, or whatever you want to do to produce algae, for example. There's also a variety of businesses that can be built around this. So we are also trying to involve the local community to get a better contact between the water that they're drinking and the way they're using it. This is a large development near Schiphol, the Amsterdam airport. This is, you're looking at a very large piece of land. It's, I don't know if you're familiar with this, but the Netherlands has indicated that we want to become the circular hotspot of the world. Big ambition. I don't see a lot yet, but it's always good to have a start. We were asked basically to look at designing the complete water systems that are available in this development, so including the black, the yellow and the grey water treatment systems, where black water contains fecal matter and the yellow contains urine, and grey water is basically water that you use in your kitchen and in your sink and in your shower. It's a long-term project that will take 20 to 30 years because it's very large, it's close to Schiphol, so you have a lot of issues, you know, with the authorities and permits and things like that, but it's a very interesting development for us. We are working with the city of Amsterdam to develop a creativity lab because we want to attract young people, we want to attract ambitious people that are interested in making the earth a more sustainable place, a better planet, and also entrepreneurs. So this is, you can call it a creativity lab or a fab lab or a living lab or whatever the name is, but the idea is that it's a meeting place for young, aspiring entrepreneurs, the public and investors to come and experiment in the field of circular economy based upon circular technologies. This is a brewery where we are involved with waterborne water, and basically it's quite a large brewery. It's the only Trappist brewery that's in the Netherlands. So you have to have monks to brew the beer. I don't know why, but that's the history. That's the rule, and they want to make the brewery completely closed. They want to make it completely circular. For us, it is a very interesting because it's a real-life test facility where we can actually really go and test what happens if you apply the Melissa technologies. Okay, and this is a picture of a mobile sanitation unit. At the moment, there are more than 65 million people have left their homes because of war or because of natural disasters. These people are all moving across, you know, the planet, and they are mainly housed in what they call informal housing places. You can also call them refugee camps. And one of the biggest problems is the sanitation. All these people have to go to the bathroom. So we decided that we wanted to do something about that and to develop a completely mobile sanitation unit that is totally off the grid, and you can transport it using a helicopter or a truck or a train or a ship. You can put it basically anywhere you want. You could put it on top of a mountain because it is completely autarkic, as they call it. This one container can provide the sanitation services up to 600 people. But that's not all. What we're also doing is that we are recovering the water that's present in the waste units, as well as the nutrients. And first we start with the water because access to clean water is essential. For example, if there has been a disaster, as you have seen now in Puerto Rico, for example, you know, one of the things is that they are complaining about, and rightfully so, is water. There's no water. I mean, there is water, but it's not clean. So this system will enable people to have access to clean water. And you could also use this system, for example, to build a new type of hotels, or apartment buildings, student homes, which is a big problem in the Netherlands, for example, but also hospitals. This can be put anywhere in the world. You put it there, You don't need power. Only thing you need is the sun, because it's based on solar panels. As you can see, well, maybe it's a little bit too small for you to make out, but we have the food production unit here, and on the bottom there is water treatment, gray, black, and yellow water treatment, and the recovery of all kinds of nutrients that takes place. And we are in negotiations with several hotel companies that are interested to build the greenest hotel on the planet. Last but not least, we are working with UMA and PTA to develop a circular economy hub right here in Malaga. We have completed the feasibility study. We are now going to the next phases. We started out with an incubator, but the idea and the concept has been growing into more of like a circular economy hub, where we will not forget the business side of things, of course, because we really do believe that if you want to facilitate the transmission to a real circular economy, it has to be sustainable, not only from the nature point of view, but also from the economics and the business point of view, because otherwise it will not work. So these are some examples of things that we would be looking at to house in this, such a hub. So we have all kinds of things. I mean, this list can go on forever and ever. It's just for inspiration. Energy management, very important new circular business models. We need to change the way we are managing our companies. Urban farming, 3D printing, advanced algae production technology. And it's all for us about the circular economy to help to keep our planet a sustainable place. And with this, I'd like to thank you for your attention. Thank you very much.